m'entends? Ça marche ou pas? Je vous vois plus et mon écran a froze, s'est glacé pendant 10 secondes. OK. Super. Vous me dites quand on y va? Je vois que mon écran, donc je vois plus du tout ce qui se passe.
On aurait quelques problèmes de son localement, parce qu'on a plusieurs ordi
OK.
dans la même pièce, c'est difficile.
Vous me donnez le feu de départ, hein, je suis prête.
Ouais, je suis là, désolé, je trouvais plus mon micro. Bah ouais, j'ai vu le mail, je viens écouter.
Thank you, and thanks everyone. As I mentioned, I don't see anything. I just see my screen, so please don't hesitate to just interrupt abruptly if you have any question or concerns or anything. The point is try to actually go, rather quickly over a brief overview of what we've done and just discuss how you think it can connect to either your work or just if you have question in general about the particular framing of that work. I'll start by acknowledging my co-authors, Adam Berinsky, Daniel Halper, Joe Halper, and Alijat Papayel, Herein, Moussa, Leila Prokatchev, great researchers across different universities, if you want to learn more also about their work. So I've been generally interested in how we can fix democracy. Obviously, it's a huge problem, not local. It happens at every scale, local, national, international, and it's a huge puzzle with all of these different pieces. And throughout the course of, I guess, a PhD and even a life, you can't really focus on all of these different aspects. So the one I want to talk about right now is the representation aspect, which is one of the huge challenges we're having these days, but in fact that is merged with the core idea of democracy is how can we accommodate the plurality of opinion. When you have people that have different opinions and you need to create a law or a rule that is going to be coercive, which means that I might disagree with a rule that I have to still accept and obey. And this just creates the core legitimacy problem of democracy, and maybe even more so a representative democracy where everyone is not all the time involved with the decision-making process, but only the few that are being selected. The way typically, this we can deconstruct maybe the pieces that up to now have been fitting within this puzzle of how you make representative democracy is this minimal viable set of common principles, the common ground on which you're going to lay the government is, the Bill of Rights. We can call it the institutional design, which is how you action on this minimal viable set of common principles. What is the institution that you design so that you can run the government? And then there is something that I really think of as a belief, the core belief that's the core of the system, which is the belief that the democratic process matters more than my opinion. And that I might lose an election, my opinion or the party I'm supporting might lose, but I still believe that there is something more to the democratic process. And I think we can make the argument that different pieces of either the minimal viable set of common principles is becoming thinner and thinner, the institutional design is failing, and the belief is also being challenged. And so the problem I want to focus on at the moment is just the institutional design. We can really think of it as a car being stuck in the mud, and you have different aspects to this metaphor. You have the terrain, the social tissue is becoming harder to navigate. You have outside conditions, the weather, and then you have your car. This is a Chevrolet from 1958. 1958 is when the latest French Constitution was enacted, and you would not imagine driving a car from 1958 necessarily today. American constitutions is, as you know, much older. So I'm really just thinking about the design of the car for the purpose of this talk. And many figures could fit in this, maybe sad description of the fact that things are not going super well. The percentage of people that have trust in their institutions. This is a U.S. Centric poll. People that have a great deal to quite a lot of confidence in the U.S. Congress, U.S. Supreme Court is at a high time low. We're talking about 7% for Congress members in 2022, extremely low. And on the bright side, a lot of different initiatives are sparking around the world to try to come up with these democratic innovations. This is one example in Nevada where during the midterms, there were questions to change the ways through which the primary and the election works. And here I don't know if you can see well from this little image on the left, but the idea was to change the way through which elections are conducted so that you don't do a first past the post where only you just choose one person among different candidates, but you can actually rank the candidate and use a particular aggregation method called ranked choice voting to actually count the vote, with the idea being that you can let people express more of their opinions and eventually converge to lesser extreme and more nuanced and more centrist winners. These two examples were really in the US. This is actually an international trend. The lack of trust in governments, institutions being challenged. This is a poll from the Pew Research Centers that surveyed around the world whether people thought that their political system needed a reform. Again, you can see, on the right, the aggregate numbers across the world. Many countries have more than half of their population thinking that the system needs to be reformed. And so, elections is basically our starting point. This is how we've been doing representative democracy for the past 250 years. And you have innovations that are happening within the scopes of elections. To name a few, just mentioned ranked choice voting as another voting role, approval voting is another one. Also, a lot of questions about what size should your Congress have. And so right now, overall, the trend is that a Congress is the cube root of the population size. Is this something that you should think about enlarging? So, this is the type of innovations happening at the election level. Another huge thing that's happening these days is this concept of autocracy, which would be having part of the decision-making, or at least the advisory aspect of the decision-making, that would be made through people sorted at random in populations. And this is already happening around the world. It's really, came with this deliberative wave that we can trace back, I don't know, to Habermas or Fishkin more recently. That's really, took off in the past 20 years, and you can find around the world examples where constitutions were written with random citizens in Mongolia, in France, in Ireland, in the UK, people being sorted at random to think about climate issues, or the gay marriage in Ireland, a lot of different issues that have been very successfully handled by citizens sorted at random. The one I want to talk about now is a concept called liquid democracy, which is yet another of these innovations, where similarly to autocracy, the idea is to remove any filtering processes that can play before people make a decision on whom should participate. But instead of taking people at random, you're trying to use a networked model to choose representatives. And so I'm going to explain more in a second what liquid democracy is, but I kind of broke this talk in two pieces that obviously are, just part of the same problem. But as we'll try to see what type of properties liquid democracy have, I break it into two. The first aspect is, can liquid democracy track good outcome? And the second will be, does liquid democracy have intrinsic procedural, good features? And so so the modeling assumption here is, we're coming into this very traditional field in math called social choice theory that was born with the Marquis de Condorcet in the 18th century. And so it's a pretty traditional, abstraction of reality that has its obviously shortcomings. But let me walk you through it. So you have n people making a vote on a binary outcome, and everyone is basically parameterized with some probability pi. And so, a very intuitive question you may ask is, let's say that you have three people whose probability of being correct are respectively 80%, 80%, and 90%. You might want to ask, how many of these people should be involved in the decision-making process? Should we just have the expert, or should we have multiple people being involved? And so obviously the probability that your expert is correct here is 90%. It's just the probability that the blue person gets the correct outcome. Now, if you look at what's happening, if you take the majority vote, which means, you take everyone and you whatever the majority says is the outcome of the vote, all of the possible events here, you can find that the probability that the majority is correct is 92%, strictly greater than 90%. And heads up here, we are really thinking about this outcome-oriented features of voting rules. And you might ask, but democracy is not about finding good outcomes. It is obviously not only about finding good outcomes. You have some epistemic dimension in democratic decision making, and it's the one we're really focusing on right now. But bear with me. I know it might be frustrating because there is more to it. But this is one way to try to reason and abstract away how we can compare different voting rules. So here typically it's this interesting fact that you actually might want to have more people, even though they are less expert, because there is some type of magic in aggregating different signals. In fact, this is an implication from this 1785 theorem by Condorcet, who observed that if you take a group whose average probability of being correct, so the average of all these numbers is above a half, then as the size of the group increases, the probability that the majority is correct is going to converge towards 1. And so, of course, any expert, especially if your support is not including 1, and we can also talk about what happens then, but your best expert is going to be bounded away from 1. The probability that one person is correct is going to be bounded away from 1. But when you aggregate all of these signals asymptotically, you can actually reach the good solution, the unknown good solution that you're trying to decipher or predict with very high probability. And obviously you can reverse this result. If the average expertise of your population is below a half, then the probability of correctness drops to 0. Another assumption that's key to this theorem is that the votes are actually being independent. But so, in context, this result came in, as I said, 1785, at a time where a lot of the political theory pre-18th century was, not all of it, but a big amount of it was not super confident in that crowds could be wise. It was more the idea of the confusion of the multitude, which is a term Madison used in the Federalist Papers. But it's this whole idea of wisdom of the crowd, of collective intelligence. I'm not sure that this is a historical fact, but at least coincidentally kicks in again around the time where this theorem was being proved, and around the time where democracies were basically being born. And since then, lots of experimentations have been confirming this idea that basically, the more the merrier if you have basic common, if you have a basic, level of information across your groups. So the idea of liquid democracy is basically to use this idea of collective intelligence, but instead of trying to use it to find the good outcome, to use it to try to find the good people. And so the way it works, liquid democracy is very simple. You have a network, like we are right now a network. You guys know each other. I don't know many of you, but basically we have some social connections that is defined by our previous interactions or what we know about each other. And the idea is that for every decision you want to make, you could delegate your vote to someone. And delegations are transitive, so that if I trust Le, who in turn trusts Julien, then we have this transitive tree, and Julien ends up being the representative for all of us. So I trust whomever I delegate my vote to either vote on my behalf or decide who should represent all of us. And so the way then you count the vote is just by counting the number of people anyone represents. The green agent represents 1%, the orange agent represents 2%, and the blue one represents 1, 2, 3, 4 people. So then you just do a weighted majority vote where the vote of the representatives is weighted by the number of people they represent. And so intuitively, the probability of correctness, if you think on that term, should increase. You can think of it like this: if you delegate to agents that are more accurate or are more experts. But the intuition you can build from the Condorcet theorems I was mentioning is that if you have a concentration of power, if anyone delegates to the same person, you're back in this suboptimal case where just you're not benefiting from this aggregative theorem because just too few people are voting on behalf of the others. And so very intuitively you can derive these sufficient requirements on your delegation graphs, which says that you should have some type of control on who has what is the maximum number of delegations someone can receive, and also you should the whole point is that you can increase the average expertise of correctness. None of this is prescriptive, so I'm not saying we're not constraining people to do this. We're saying people do their delegations, and then if the delegation graphs are such that the max delegation number is sublinear and the average expertise increases, then we should be in these cases where liquid democracy has interesting guarantees. And so I don't want to go too much into these type of details, just giving you an overview, and we can go back if you have any questions. But basically, we model how people delegate through these random delegation models that are just two functions, and basically this. So we it's like we model at the high level how people delegate, and then we look at the graphs that are being induced, the random graphs that are being induced by these delegation mechanisms. Yes. Right. Yeah. So it's just if you have n people in the group, you don't want you want that the number of delegation the number of people that someone represents, so the total number of transitive delegations being received should be something of the order of like n to the alpha, with alpha strictly smaller than 1. Or anything that is a sublinear function like log n or whatever. Just not, it's not a fraction of n. So it's that it won't be worse than direct democracy. Yeah, asymptotically, which is, you can't be in a situation where when we say that the average expertise in particular increased, let's say that, the average expertise was 0.1. If you go to 0.2 with liquid democracy, you won't go to 1, but you will beat liquid democracy. So what we will beat direct democracy. So these theorems tells you in the intuition behind the criteria that we use is that in most cases you won't be worse than direct democracy, and in some cases you'll be strictly better in that direct will go to 0 and liquid will go to 1. On how people delegate? Yeah. So, and again, we are trying not to again be prescriptive. We're just saying that people will have different ways of whatever. So we're trying to have a macro model for how they delegate, and which we're not saying is like how people actually think through this entire. It's not a cognitive process. And so the way that we delegate was my probability of delegating depends on my expertise. So we have this like delegation function that depends on your expertise. It can also be a constant function if you think that there is some like intrinsic reason why people delegate. And then the probability, and then when you choose someone, you basically put different weight on different people, and we say that this function is parameterized by your expertise and their expertise. And again, they do not capture macro trends. The capture macro trends. It's not like, we're not saying it's like motivated reasoning. It's a way to try to abstract away how people actually, delegate. Oh, so we don't know. This is not the assumption. We're saying, these functions can be like decreasing or increasing. It's the way through which we capture what we're seeing. We're saying, people make delegations, and we're going to try to reconstruct how people actually delegate, whether they do what you said or not. But the idea is that, let's say that, for instance, if everyone delegates to like the most expert person, this could be a rule where like delegation is like 1 if you're the most expert and 0 otherwise, and then the phi is just 0 on anyone and 1 on the person who has maximum expertise. This obviously would be a scenario where that would lead to linear number of votes. And so basically the idea is that we can map different classes of functions to the criteria. So we can say, if people delegate according to Q and phi, then liquid democracy doesn't work. If people delegate according to other Q and phi's, then liquid democracy works. Yes. So Q and phi are abstraction of how people make delegations. And the probability, Q is just the probability that I delegate. It's like my, will I more often want to vote myself or delegate? So this is like my delegation function. And phi you can think of as a gradient, which tells me, okay, so I delegate, then I look at people around me and who do I give my vote to? And I just put different weights on different people. And this creates a gradient over where the flow of my delegation can go. And so to your point, skip that part, to your point, identify is classes of delegation functions. And so as your intuition was going, of course, for instance, an obvious one is that
Sorry, I have a quick remark. Like, I don't know if it's just me, but sometimes like you speak way faster, and maybe because of my connection, like it kind of get lost.
Okay.
So, yeah.
Thanks for letting me know.
All right, thanks.
I'll slow down then.
I mean, not necessarily slow down, but
So-
have more of a consistent speed.
Okay. Thank you for the note. So so here what we see is the different classes of function that map onto liquid democracy working, well. And so what you have here is that this, maybe the first one is the most intuitive, which is that when you delegate, you only delegate to the people that are strictly more expert than you. And then you can delegate with, everyone can delegate with the same probability. That does not matter. And so, the reason this is kind of intuitive, but what could not be intuitive is that, let's say that everyone just delegate to someone that's better than them, and your graph is completely connected. Then what would happen is that only the best person will end up having all of the delegations. And so and here what can break this is the fact that some people will constantly, you have a constant fraction of the population that just won't delegate. But basically, there is an interplay also between these delegation functions and the graph topology on which you're working. The other functions that we have is that you can delegate completely at random. It doesn't matter. It's just that your probability of delegating decreases with your expertise. And otherwise, this one is maybe the most nuanced and interesting, which is that I can delegate to anyone, but I just put a higher weight on someone who's higher expertise. But if I'm like expert with a probability of being correct of like 90%, in expectation, I'll always delegate to someone who's worse than me. It's just that I'm more likely to give my vote to someone with 50% than someone with 10%. And so, at this point, these are really just kind of abstract classes of delegations. It's not actually proving that you have sublinear delegations, and all of this is much trickier. But this is really the snippet of how we map these delegation rules onto what's happening. But the really interesting question for me was, how does this hold in practice? How do people actually delegate? And is there any meat to think that these delegation patterns are met in practice? And so we ran 12 liquid democracy experiments. Each experiment had at least 40 liquid democracy tasks. So we have a bunch of these delegation graphs. And we also have a way to construct the liquid vote and the direct vote so that we can compare basically exactly what we were studying in the theoretical paper and try to understand whether people delegate to higher or lower expertise others. And so what you see here is that 0.6 means that this person is a 60% expert and this one is a 100% expert. And so what we see if you just eyeball these results is that across the different categories and across the different experiments, you see this constant kind of increase in probability of correctness. We find significant result of significant improvement of liquid democracy, but only of 4%. So we only increase the correctness of the groups over different experiments by 4%, which is it's small. Also notice that in fact all of the this is aggregated across a lot of questions, and this is as well. This is like tasks questions, but in general the predictive tasks were easy in a sense, in that the baseline is that actually many people know about the questions we've been asking. But maybe the most interesting part is that if we reconstruct our Q function and our phi functions here, what we find is that they fit into our classes of delegations. That's the last one. In fact, it's a fourth one that comes. It's a mix of the second and third class. But basically, we do observe that people that are more expert for one particular question are less likely to delegate. And also that when delegation go, people, even though they not necessarily, the questions we ask had nothing to do with why the group knew each other. So we didn't really have reason to think that someone in the group would know who knows more about astrophysics than someone else. But we did find this patterns of increasing trends in who people delegate to in the process. So, yes. Yes. So indeed, this is absolutely not something that we model in this theoretical work. We do have in like anonymity in a sense, is that you don't know who you're delegating to. I completely echo your concern that in fact, some people are going to be more well known than others, and this is of course a very imperfect abstraction of reality. One of the things we're interested in understanding is whether we know in some of the groups we had people that were much more central than the others, and that they were like the organizers and they knew everyone. And it was interesting to us to see whether these people would get more delegation or the experts. And of course, I'm sure that a little bit of both is happening. In fact, we find that we have very few instances where people have a huge amount of delegations. So overall, delegations get spread out over different tasks. So it doesn't seem that it's as much about who's the most central in the network, but more about who knows more in these experiments. But again, a huge caveat is that we ran these experiments with max 50 people in groups that were, not polarized, not trying to fight for power or anything. So I think all of this intuition that we built is really for a very particular scenario where you have a group working toward an outcome together. And that these maybe you can mitigate in a sense, or that the network effect are not the only thing that matter at that moment. But then obviously some people, and then the extra layer, which is something that we're considering for future work, is complexifying the topology of the graphs on which we're making this analysis. One way we could do is just saying that in fact we have a very high degree node in our network and see how this changes the results I was showing before. Okay. Yeah, and I'm almost done, so I'm also happy to just take all of these questions. And something I always say is that by no means this is first of all of this kind of math fields trying to model the decision making is never making a perfect model. There's no such thing. We were trying to build intuition on how the systems work, and then trying to understand what is the intuition that works in reality, and when it doesn't work in reality, can we go back to the models and see how this inform one another? And this is obviously a very, in a sense, first step in this field of studying this like delegation based or trust based endogenous kind of systems. So the conclusion of this part. Yes.
Sorry. Can we go back to the previous graphs? Like, my question is basically the pink graphs, like basically they show an upward trend, right? And does this mean like the more people delegate, the I don't even know, like the more experts will actually vote?
So if I understand your question correctly, these graphs mean that basically if I'm expert with, like, if I'm non-expert basically, so here you fix the probability of the people who delegate, and you look what is the weight that they put on the others, and you it's like 0 you put a weight 0 on like the least expert, you put a weight like 21% on a bit more expert, 22% on this one, and like 40% on this one. So you fix the x coordinates and you look at what is the weight that you put on people around. And again, to Lee's question before, people are interchangeable. Is that what matters is their expertise, not their identity.
I'm not sure I understand. So yeah, because actually I was confused earlier because you mentioned like we can interpret like phi as a gradient, but I don't see why. Like, yeah, can you explain a bit more on that if you have time?
What I mean by gradient is when you think about flow in networks, when you have a network and you can define this, like, I don't know if it's a fluid mechanics, I think is where I've seen it, terms where you have your graph and then you have this like gradient flows within your edges that indicate where you are more likely to go based on when you start. So I'm starting on my node, and then I can look at what is the most likely path I take, and this depends on the weight I put, and the weight are completely defined by these 5 functions.
Right. And so Yeah, and then in the light of this, can you rephrase what you just explained about the ping graphs?
So let's say that, I'm a node and I look at my neighbors, and my neighbors have different expertise. And so the weight that I'm going to put is increasing with their expertise. So if this is the little
Okay.
drawing here, it means that I have a higher chance to explore the edge where the person has the highest expertise.
All right. Okay. And I'm still confused. Like, is this empirical data, or is this like a posteriori optimization?
This is empirical data. This is based on 12 experiments that we ran with total. So we had up to 40 questions grouped in tasks. I don't know. We have like 500 maybe delegation graphs or something like this.
All right. Okay. Thank you.
And the experiments were meant to test the theory. So it is prediction type of questions where there is a right outcome and we can measure actual expertise.
All right. Okay.
So this is the whole idea of this research, is that we want to know whether people can, do they know anything about the others people's expertise, and would they be more swayed, as per Lee's question, by popularity of people or expertise. And so, I mean, when we tell them, we're going to run this voting experiment, and we don't explain them what liquid democracy is or anything, and we tell them, look, it's like sports prediction time. Do you want to vote yourself on a bunch of sports prediction questions, or do you want to delegate your vote? And then people delegate their vote. And then you see this like very kind of, in fun little delegation graphs where sometimes you have like components that are being created where, like these two people knew an expert who trusted a non-expert, for instance. And here it's kind of the opposite, where through this transitive delegation, like, this one apparently knew each other, this one knew each other, this one knew each other, and we end up on like one of the experts. But we have the questions we ask had nothing to do with like we run these experiments with companies, universities, and research groups, and we ask questions about prediction in soccer, basketball, constellation, where I don't know, like landmarks are around the world, flags, like stuff like that, on which we didn't have reasons to think that they knew much about things. And again, it's like this thing that maybe I know that my friend knows something, but I don't know really the others. But then that friend knows something, and collectively we basically leverage collective intelligence not to know what is true, but to know who knows about what is true. Yeah. Varying degrees. Some of them were like, like companies of people working together for 10 years, or there were like a class of undergraduate students that were just in this one class together. So we have a lot of variability in the strength of the networks. And so yeah, on the outcome perspective, what we found is that liquid democracy can be leveraged to find the experts through this endogenous process, where you don't have like someone outside saying this is an expert, this is not an expert, it's completely endogenous. And in a way, we displace this idea of collective intelligence from knowing enough to knowing enough about something to knowing who knows enough about that topic. Again, as I mentioned, I don't believe that this would scale necessarily well, or I don't know that they would scale well to a country. All of the experiments, as I said, were on small contexts with a well-defined objective. So it's still a really constrained environment in which the theory applies at this point, and we're trying to get into broader scale experiments, but it's not something we've done so far. Yeah. Wait. Sorry? I don't know. Sorry, I was thinking about something else. No. Yeah. Okay. Like the log of the pi over 1 minus pi thing. Yeah. We've not, and one of the kind of issue is that if your pi is smaller than half, then your weight is negative. So like it's hard to So we would need to only compare it to the people above a half, basically. But something that we're thinking about is to try to find the like Q and phi. If I give you a graph topology, what Q and phi would get you epsilon close to the log weights, but we've not done it, and I've not compared it in the theoretical empirical things. But it would be fun to check indeed how it compares. And so the last thing I wanted to say is just that I started this work trying to understand what was the complementarity of diversity and expertise in these processes, and all of what I told you is about probability of correctness, which is maybe an interesting metric to think about these innovations, but absolutely not the only one. And in fact, a lot of the procedural aspects of how this works, and that a lot of the legitimacy of these institutions also come from the process that is being used. And so I was interested in understanding what type of intrinsic guarantees liquid democracy has. And so I've been working in political theory as well in the past year and a half to work about this, to try to answer this question. And I'm still not sure how to do a political philosophy presentation, so I'm going to talk much more and use slides much less. But basically, some of the core ideas is that we associated the democratic process with elections for the past 250 years. We have both, rational reasons for that, but we also have symbolic reasons for that. And there is a very interesting history of how this came about. But in fact, these are two, some democracy don't use, or in the past didn't use elections, and some places that use elections are not democracies. So, the first idea is to try to break apart these two notions of like democratic process or representative processes and an election. And then a philosopher that's been really influential in trying to redefine the non-electoral framework is Hélène Landemore at Yale University, and she's been talking about this concept of democracy, which is another way to think about legitimacy, not through elections, but through how much, how inclusive is your process, and how does it treat people equally, and so the idea here with liquid democracy is that you have an inclusion of everyone as being a potential representative. It's not just that people can, it's not 1% 1 vote, like we're all included in that we can vote, is that we're all included in that we can become a representative. In terms of equality, you have equality at the initial stage, but then obviously when people have their vote being aggregated, you don't have equality anymore in that your vote depends on how many people delegated to you. And maybe the most important piece that get me really interested in these different democratic innovations is this idea of co-authorship. Is that, when you'll be coerced by some rule, it might be hard to accept something that you did not agree with, but the idea that you can co-author, and it's a term actually I've heard a lot from a professor here, Deborah, which is this idea that we are all, everyone is being included in how we design the processes that are going to rule us. And in a sense, the processes that are ruling, especially in this country here, have been written so far back that people don't really have this sense anymore. And trying to think innovations, democratic innovations, in terms of how can we include people so that they are actually feel connected to the processes, and then the outcome, to me, is as important as trying to think about a rule that will lead to good outcomes. And that's it. So I'm happy to stop here and then just go into some discussion, if I can find back my way. I lost you. Yeah, it's really exciting. I think I don't know if you see me because I just see you, Le, everyone as, and I don't know. Anyhow, sorry if I don't see myself, so which is completely fine. But I don't know if you can, or if it's just that my browser shut down or something. Okay, well, it doesn't matter. No, so it's super exciting to hear that that you're juggling with some of these ideas. The So, I've been working with a few places that have been trying to implement liquid democracy in different setups, and the few, and it's like super recent still, and so it's hard for me to know exactly how it's going to go over time and long term, and also at scale. But the few things I realized is that that you have a ton of like tacit information or tacit knowledge that people have about one another in an organization that just a central planner doesn't have. And what I feel I've seen successively happening is that you can have this type of like local information that emerge. I've been in one of the contexts I'm working in. It's also an online community, so people do not necessarily know each other outside of the of the platform, and so some of the questions we still have as we're deploying this is how much people know about each other by just seeing the pseudonyms and knowing about um, their just whatever ratings that they've put on predictions. And so something that we've also been working on at the same time is bringing up some type of chat or collaboration platform where people can just meet around a center of interests and track what was the past predictions of someone, or what was the past interactions of someone with different things. And so this is still a work in progress, and I don't I don't know if it's going to play out well or not well, but yeah. So I think these are my kind of preliminary answers. So there is a bunch of work that has been trying to extend the counter-surgery theorem in the case of correlation, which basically means that you can go up to some level of correlation up to when concentration aggregation doesn't work. So the I forgot the name of there is a paper that basically quantifies, if you look at the pairwise correlation, tells you what is the average pairwise correlation you can have across all pairs such before aggregation breaks. There is also a very cool paper by Elhanan Moussel and co-authors from 2006, I think. It's called a weighted, something like a weighted law of large number, which they basically generalize Condorcet with correlation and weights. So it's like, now you have like the sum of the WIXI, and you assume that you have some correlation structure. And so basically what they do is they define, I don't know if that it's useful for your purpose, but they define this idea of an effect, which is the effect that someone has on the outcome, which is, it's basically proportional to the correlation there is between you and the vote, or the outcome of the vote. And in fact, you can express that depending on the settings, you can express this correlation itself as something more or less nice. But then it's the same. It's like you have a bound on the max effect that someone can have before aggregation fails. Now, maybe I don't know if there might be something interesting. Precisely like the weighting thing you were mentioning before. Like in a sense, the weighting is meant to account for difference of expertise. I don't know if there is like a re-weighting function that accounts for correlation. I'm not sure, but I would suspect that there is maybe something. Oh, well, so maybe there's none. But I'm happy to send over the few things I mentioned if they're useful.
Yes. First, congratulations for the very interesting work. I'm not a mathematician, so I was a bit lost with mathematics, but I actually got everything you said, so I can discuss it. I'm not good enough, but I have to say it was very well presented, so I got everything. Maybe I missed it, but I was thinking of the parameters you changed in the number of times you can delegate the vote to a person and stuff like that. Did you find some results, some optimal results? Or did I miss something, or did you discuss them? I would be very interested in knowing which parameters are optimal, what works best in your system, and why, or what reasons would you give to this?
So on the liquid work, we don't have optimal results. So in that, we have another work where we look at what is the optimal size of a Congress, which we like, it's like how many people you need to maximize probability of correctness. Here, what we're looking at is when is like situations where basically the probability that liquid democracy is correct goes to 1. So, and there is a difference between optimality and convergence in that you can think of a scenario where you maximize the probability of being correct, and this is using the weighting rule that Lev was mentioning. If I'm given expertise, I can weight the votes in a certain way so that I maximize the probability of being correct. And you can ask another question, which is, if I have a bunch of different people and I aggregate them with some rule, will I be likely to converge asymptotically? So is it likely that the probability that I am correct converges to 1? And you don't need to be optimal for that. Most cases are not optimal, like you don't maximize the probability of correctness for every n, but asymptotically you actually converge. Does that make sense?
Yeah, I got it. I was very interested in finding some parameters which would be better than others. So it was not yet
okay.
Yeah.
And so
yeah.
So I mean, maybe the thing I can add to that is that, so I'm not talking in terms of optimality, but what we do find is the results are not, though we might be able to infer something about the like maximal number of hops that can go from me to my delegatee, but basically the parameters that we have relate to the maximal weight that someone can have and the average expertise that you have. This was the sufficient conditions I was showing. You can get, these are only sufficient conditions, which mean that you can have, they are really like heavy in a way. And we could actually assume much less. So for instance, you could have scenarios where someone has a fraction of the votes, but then you need to look at how many weights do the other people have, and what is the relative expertise between the heavy person and the other persons.
Yeah.
So these are the parameters that we tweak or we study.
Oh, yeah. So that's interesting. I had another question. It's a bit conceptual, but maybe I missed it also, but I don't know what you call correct. I will be a bit more explicit. Is finding the right answer considered as correct, even when you use a flawed reasoning? When you find the right answer, but do something, miss something, or just say it randomly, or had something in mind and forgot it. And I think the whole process might be different. And I don't know if you call this correct. I don't call this correct. So what is the definition of correct, and how do you assume it?
Yeah, no, that's a really good question. And and I want to answer it at the like concrete and a conceptual level. Conceptual level first. So many questions don't even have a correct outcome. So this is just one aspect of decision making that we care about, but it doesn't convey well to a lot of different other questions that are really value based and moral based. Now, so to your question of does it matter how you reason? When we model expertise, so you have like being correct and incorrect, and this in the case where it's a binary outcome, like a coin will be correct half of the time. But the coin's expertise is a half, right? If you have an unbiased coin, the probability that it's correct is a half. What would be captured by the model is, you can think of this probability as if I repeat the experiment many times, what is the average number of time where I will be correct? And if I have a very flawed reasoning, like I don't know, if I'm thinking about climate change and I hold a like biased wrong belief or something, maybe sometimes I'll get correct on some questions, but or maybe a more concrete example. Let's say I'm doing like soccer prediction and I know absolutely nothing about soccer. I don't follow it. But my partner is from Barcelona, so I just want that Barcelona wins all the time, and so I'm constantly going to say, like, anytime there's a game, I'm going to say Barcelona wins, and then whatever. Maybe I'm extending to Spain. Like if there's a Spanish team, I say Spain wins, and I'll be correct, a fair amount of time. Like Spanish teams win a lot, but I'll be also incorrect other times, and so these would be captured by there's my probability of being correct. That would be, lower than a half, for instance, if depending on my biases. Does that make sense? So you can capture it by the expertise, but then at times I'm going to be correct even though my reasoning was flawed.
Yeah, it's clear. Yeah, so basically by repeating the number of situations you can treat this. Okay. I had a question during the process, during the method. Do the candidates talk to each other, or is it very separate? Is there an influence, a possibility of influencing someone?
Yeah, that's also a great question. So most of the experiments, and I ran them in workshops, many were online. So my understanding is that they were not talking. I don't know, maybe they were Zooming, like messaging and other Zooming, but I don't think that was the case. One of the experiments that was ran in a research workshop, people were in a room, and I don't know how much they communicated. But overall, there was no communication, and people were not even in the same room, except for one of the research workshops that I was online when it was being ran. I was not in the room. So, yeah.
Yeah, so I think it could be interesting to test both to see if it's the same outcome when you have you allow them to talk to each other and you state as a rule they are not allowed to communicate.
Yeah.
Interesting to check if is it a confounding factor. And I was during I read the presentation in advance and I was very interested. And there is a democratic aspect of it, which is very interesting. But in my opinion, maybe I'm wrong, there is mostly no correct answer. And you also said it a bit on the earlier question. So I would be interested in testing not a correct or a wrong answer, but testing a political result. Having some points which are from Democrats and from Republicans on the paper, and then checking if when you ask people what they want to decide, if it goes to Democrats or to Republicans, with the people not knowing what is from the Democrats and what is from the Republicans, and just seeing if their political stance will go towards one place or another. And I think this could be interesting to test without having this correct or incorrect answer.
Yeah, so absolutely. I think the way I kind of thought about it during my PhD was you have different dimensions in decision making. One is correctness, one is procedural, and like it's so hard to model everything at once that it was like, can we just reason and one at a time? On the political thing, I've been living in the US for 6 years now, and it is very polarized. And so my expectation was that it's why I think at some point I said, if we were to scale it up at the level of a nation where we have political factions that are, opposing one another, I don't really have faith that it would, depolarize. I guess is the first thing I want to say. But actually what we did is we ran something similar to what you mentioned. It's obviously still, not in a polarized environment, but at the level of my department at MIT, we ran an experiment with the entire department. It was like the end of a year, and we were supposed to set up a few of the vision setting items for the next few years. And like in any organization, people disagree and have different you have different talents that just like different things, and that can be more or less vocal about it. And so we ran this big experiment where we had about for my standard at this point working with groups, we had 120 people, I think, which is about 2/3 of the department, and we had 11 questions. So, and then we asked, a vision setting questions. and so I can't tell that people that didn't think something would delegate to others. Like I could not really do this like Republican Democratic mapping that you or idea that you had, but a few things that were interesting that we saw was that the diversity of the people that ended up making decisions was much bigger, or like the pool of people that made decisions through liquid democracy was much more diverse than the usual suspects, so like the leadership teams or whatever, that would be the one that typically would get the direct delegations, in fact. But there was an interesting kind of like reshuffling of some of this delegations. I'm trying to, because this experiment is really descriptive, because it's hard to quantify anything on these descriptive questions.
Have we lost her?
Who?
You.
Me?
To the
Oh.
end.
Sorry, I'm here. I'm not lost myself, and I've heard you all along, so I don't know where I got cut.
Oh,
I don't
just
know why my
last
camera's not
sentence.
working.
So,
Oh yeah, and I was just saying, if there is anything you think would be valuable to get from this data, let me know, because if I've not done the analysis, I'll do it.
yeah, well, I'm very interested in your work. It's really interesting. Thank you very much.
Thank you. And I'm rewriting one of the empirical papers with more robust methods. So it's work in progress. If you have any comments, I'd be happy to include them. I guess homogenization. You if you want to have any like type of diversity in your feed, you might end up overfeeding on that of a community that you predefined, and that might be suboptimal in the sense that you might just lock people into these different bubbles. I guess would be the biggest fear is basically having engineered filter bubbles. But in a sense, I guess you're using some type of the how's it called, the probability matrix factorization, like the Netflix model. Is it some of what you're using for to reconstruct some of the recommendation? Okay. Okay. But the question you were asking, just to be sure, was in a scenario where you would have personalization, right?
No.
Okay. Okay, so yeah, so my first answer was completely, not appropriate to the question. So, but wait, why does that necessarily break the linear assumption? Couldn't you have some type of like, if the weights are like, well, I mean, I guess you have yeah, sorry, go ahead. Okay, of all the users. In fact, so there is a recent other liquid democracy empirical paper that just came out on Archive a few months ago that I feel might resemble more your setup and has negative results. So you should be aware of it before you're doing the implementation. Where what they have is that they define to start with who's going to make the decision, and then people say I want to delegate or not. It's more I don't have time or I have time, and then they randomly assign. So like effectively in expectation they assign, like if you have n people that participate and like n-1 that don't participate, they give every person that participate like whatever m over n minus m votes, and then they showed that you have an equilibrium where things could go well, but that in practice people go delegate too much for this equilibrium to be met. Is I think kind of the spiel, and their results are negative in that they don't think liquid democracy is actually helping in that scenario. So you might want to look at it because it might be more the case of your setup than what I've been studying. I mean, in fact, they did this recently I learned this 2 days ago in the Convention pour la fin de vie, the end of life convention that's happening in France. In fact, so it was at random, and then they had a process, and then they wanted people to write a final thing, and they used liquid democracy there to identify the people that would be trusted by the larger group. Another idea I've entertained is the other way around, where so maybe would be applicable to your case, where you tell, okay, like do your delegations, but then into the question of the person on your left lay, I don't know, I didn't see Louis. Okay, is that so the biggest problem with this system would be that what if Lay concentrates all of the power? You would basically see like les vides on tournesol. But then something you could do to kind of like use it but mitigate would be people do the delegations, and then Lay has a weight, Louis has a weight, like everyone has a different weight, and then when you do the ranking, you use you sample a group of people, and their probability of being sampled is proportional to the weight they had, to the relative weight they had. So you had this element of like it's more likely that the people that were most trusted are going to have their choices ranked higher up, or their whatever rated higher up, but you would still have this amount of diversity and like randomness that would kick in, that might mitigate some of the concentration of power. Okay. There are also two papers that are going into this direction. One is the original paper in Liquid Democracy by Enson Kang and the team, Simon McKinsey and Ariel Procaccia, where they have this cap, I don't remember how they call it, but like cap algorithm where basically like they trim the tree. If someone has reaches the max number of delegation possible, this person just can't get anything more. And the other paper is by Paul Gulls and Ariel as well, Ariel Procaccia, where what they say is anyone can choose two or like K delegators, let's say, could choose K delegators, and then you have an algorithm that uses exactly one of the K delegators that was mentioned, but use the set of delegators that minimize concentration of power. As a, yeah. Yeah. Yeah, sometimes I feel that maybe the liquid democracy paradigm is not that well suited for decision making. I think it comes with issues, and I don't know. I now I tend to think that maybe it complicates a bit too much. At least when you think about like a Congress, I would not be in favor of electing Congress members with liquid democracy. But I feel that maybe it would be an interesting just way to model social connections, because a lot of it happened like this.
Yeah, actually, like I was. I mean, I think it's very relevant, but initially I was a bit skeptical, like because about your question, Luis, because I feel like there's quite a clear distinction between trust and expertise. Like to me, the problem is more about trust, and it is not clear at all that you can apply findings of fluid democracy to trust-related problems. I don't know. So what is your take on that, Manon? Actually, like, can it be applied? Because even politics, actually, it's a lot about trust. Like, because we don't really have technocracies. Actually, the technical experts are not even elected. So, what's your take on that?
And can you, why do you think it would not be applicable to trust problems?
Because we don't elect leaders, or we don't vote for people for their expertise, but rather for a more general concept of trust, if that makes sense. Yes,
I see,
really,
but
like, yeah.
but so I mean, I think this is a bug. It's not a feature of the system. And this is, when I think about I call this talk the institutional design problem because I precisely think that this is part of the institutional design problem. Now, you can ask the problem as, which is like the constant struggle with this studies is, it's like the chicken egg problem. Do you think that the institution would change this bug, or do you think that we first need to change the back? Like, can an intervention of changing the voting rule can have the right impact? And I don't know the answer to that. And
Yeah, I think to me, like, we should first move to more like elected technical leaders, because for now it seems quite far far off from that kind of that kind of voting system. Like, yeah,
But I think so. To
absolutely.
this, my intuitive answer is that we have a supply problem. I don't think we have a demand permit. I don't think that people are not like, I think we're capable of like voting for people that are more or less expert. But we like when you have to when you vote in an election, you're not given a choice between expert one and like politician one. You're given a choice between like a bunch of politicians that are not necessarily technocrats. And I mean, I don't even know that I want a technocracy either. But I think that we have a supply problem. I think that like the people, this filter that decide who's running, it's huge. Like in the US, it's 0.001% of the population that funds the campaigns of the people that are going to run. And then, this applies this huge filter on who's running in front of you. I'll have to go, unfortunately. I have a meeting in 31 seconds. And I'd love to, talk more and help in any way I can with any liquid implementations at Tournesol.
Yeah, I guess maybe other people can stay to keep the discussion a bit, I guess. Yeah, let's stay in the meeting if that's okay for you guys. Except Manon.
Yep, I'm running. Thank you so much
Yeah.
for the opportunity and for